I'm going to start this video by drawing a right triangle, and then I'm going to draw an inscribed semicircle. This semicircle has a diameter that coincides with the base of the triangle, and it is tangent to the hypotenuse at this point. If the legs of the right triangle are 6 units and 8 units long, then what is the area of the semicircle? Want to give this a try? You know what to do. Press the pause button and grab some pen and paper. Lucky for us, the solution to this problem appears to be a straightforward one. Solve for the radius length and we can solve the semicircle's area. In order to do it, we're going to need the right triangle, and that's where we'll start. Label the vertices as A, B, C, D, and E. We're going to find the length CE using the Pythagorean theorem. According to the theorem, the square of the hypotenuse is equal to the sum of the squares of the legs. We're going to use this theorem on right triangle EAC. CE squared is equal to 6 squared plus 8 squared. 6 squared is 36, while 8 squared is 64. CE squared is equal to 36 plus 64, or 100. Take the root of both sides to get CE equals 10. The length CE is 10 units. Moving on, let's draw the radius from point B to point D. Let R be the radius of the semicircle. Since all the radius of a circle are congruent, then AB must be R units long as well. According to the tangent of a circle theorem, there's always a radius that is perpendicular to the tangent of a circle. This means angle BDC is a right angle. So is angle BDE. Recall that the two tangent lines to a circle that intersect externally are congruent. So the length DE is equal to 6 units. Now let's try to find the length of the segments DC and BC. Using segment subtraction, we find that segment DC is equal to 10 minus 6, or DC equals 4 units. Additionally, we find that segment BC is equal to 8 minus R. I think we're getting close now. Let's shift our focus on the right triangle BDC. Once again, we're going to use the Pythagorean theorem, but this time to find the radius R of the semicircle. 8 minus R all squared is equal to R squared plus 4 squared. 8 minus R all squared means we've got to multiply 8 minus R to itself. So 8 minus R times 8 minus R. 4 times 4 is 16. Next, in order to multiply binomials, multiply all the elements of one binomial to all the elements of the other. 8 times 8 is 64. 8 times negative r is negative 8r. Negative r times 8 is negative 8r. And finally, negative r times negative r is r squared. And then copy the rest. Now it is time to combine and cancel out similar terms. Negative 8r minus 8r is minus 16r. Cancel out r squared on both sides, and then transpose 64 to the other side and make it minus. The equation becomes negative 16r is equal to 16 minus 64. 16 minus 64 is minus 48. Divide both sides by negative 16 to get r equals 3. The radius is 3 units long. Now that we know the radius, we're almost done. The area of a semicircle with radius r is 1/2 pi r squared. Substitute r equals 3 into the formula. 3 squared is 3 times 3, or 9. Therefore, the area is 9 pi over 2 square units. So, did you get the same answer? If you have any questions and suggestions, let me know in the comments down below. Thanks for watching.